Okay, so we're going to continue now with hypothesis testing, and we will take a look at the PowerPoint slides that our textbook actually has provided for us, and use that as a way to kind of go through the material in a bit more formal manner. So I'm going to kind of go through some of the PowerPoint slides, but then I will embellish it with um, some additional stuff. So as we see here, hypothesis testing can be used to determine whether a statement about the value of a population parameter should or should not be rejected. In other words, we have an assumption about a population and we want to test it, as I just mentioned in the first video. Okay, so we'll assume it's true, look at some sample evidence and see if in fact the sample evidence looks like that population value. So what we do, to be more formal, is we frame two hypotheses. The first one we call the null hypothesis, which is essentially stating that what we believe to be true about the population. All right. But then what we want to prove, we call it HA, or the alternate hypothesis. So for example, if I go back to the example about the average performance of students in an exam in statistics, remember we were using 66%. My null hypothesis would be that the average is 66, but then with the sample mean of 80 that I got, I will have to test, or I would want to test, that the average is actually higher than 66. Okay? And that sample evidence certainly seemed to be suggesting that. So developing the null and alternate hypothesis is, so sometimes it's not always obvious, but one of the things that we have to keep in mind when we're structuring the null hypothesis is that the null hypothesis must make a statement about the parameter being equal to a particular value. All right? So that's one of the things that we know. Also, it says that care must be taken to structure the hypothesis appropriately so that the conclusion that we make is essentially the appropriate conclusion. In other words, the material or the evidence that we have to test the hypothesis, we could actually use it to try to come to that conclusion that we want. All right. The context of the situation is very important in determining how the hypothesis should be stated. So depending on the problem situation, we have to adjust, or not adjust, but be careful how we state those hypotheses. As we get through the various situations, it would make it easier for me to be able to demonstrate what is being talked about here. All right. So this just in terms of the whole idea of looking for evidence. We're told here that many applications of hypothesis testing involves an attempt to gather evidence in support of the research hypothesis. So usually you're not trying to prove the null hypothesis, you're trying to support the alternate. So you'll say, I'll assume that the average performance on an exam is 66%. But now I want to find evidence that is actually different, or is more, or is less than that. So this idea that the applications involve really trying to find evidence for the research hypothesis. So for example, the prosecution is trying to find evidence that the person is guilty, not trying to prove their innocence. Okay? That's never what it's about. So in such cases, it's often best to begin with the alternate hypothesis, that's in other words what we want to prove, and then we go back and then we frame the opposite of that as the null hypothesis. So here's alternate hypothesis as research hypothesis. So if we were testing, for example, a new teaching method, say using MindTap, right? So, and then compared to our traditional methods, we could then say as our research hypothesis that MindTap gives us better results than our previous method. So the new teaching method is better. But what we'll say is, no, there's nothing wrong with the old teaching method. So we will assume that the new teaching method is not better than the old method. All right? And so that's what we have in the null hypothesis. Alternate hypothesis, that the new teaching method is better. So here's another one. A new sales force bonus plan is developed in an attempt to increase sales. All right. So, of course, what you want to know is whether or not that sales force or that sales bonus plan is actually going to help to increase the sales, because that's the whole reason why it was developed. So, we will actually say that what we want to prove is that it actually works. And so therefore we want to show that the bonus plan increases sales. So what you'll say is that, no, you kind of, basically what you do is you become the pessimist or the skeptic. And the skeptical position is the null hypothesis. No, that new bonus plan is not increasing sales. So you always be the skeptic, but then you try to find evidence to support the research hypothesis, all right? Another one again, a new drug is being developed with the goal of lowering blood pressure more than the existing drug. So what the optimist will say, hey, that new drug actually lowers blood pressure more than the existing drug. The pessimist or the skeptic will say, that new drug does not lower the blood pressure more than the existing drug. All right? So new drug lowers the blood pressure versus it does not. Always remember, one is exactly opposite the other. All right? Keep that in mind. That's another one. Or is this another one? Null hypothesis and assumption to be challenged. So we might begin with a belief or an assumption that a statement about the value of the proposition is true. So that's basically the null hypothesis. Then when using a hypothesis to challenge the assumption and determine, we are then using a hypothesis test to challenge the assumption and determine if there's statistical evidence to conclude the assumption is incorrect. Now, one thing that's important is this whole idea of statistical evidence. The proof that we gain is not incontestable proof. By that I mean that we take a sample and we look at the way the sample is leaning, and we set some boundaries that we're going to use to say, you know something? If we are in this zone, we're going to reject the null hypothesis. In other words, if our z values or t values are very big, that means that the sample values that we obtain are very different from the mean. Then we reject the null hypothesis. But remember that this is based on statistical evidence, a sample. And if we generate another sample, we could get a different set of results. So what we have to do is really make sure that we set our criteria for rejecting the null hypothesis to be very, very tight. So that way when we do, we're taking very small risk of making an error. That's where the errors in hypothesis testing actually comes in, okay? So now let's start getting into starting to put numbers on things, all right? So as an example, a label on a soft drink bottle states that it contains 67.6 fluid ounces, right? That's the claim. Null hypothesis in that case would be that is correct. But what if we want to prove that actually there's less than that in the drink? So in that case, if we want to show that there's less than that, we will say, well, what I want to prove, HA, is that the average is less than 67.6. So my null hypothesis, I'm going to be the skeptic and say, well, no, it must be 67.6 or more. So mu is now greater than 67.6 fluid ounces. So you see how, I have less than or equal to. In the alternate hypothesis, or the research hypothesis, we never have an equal sign in there. Always in the null hypothesis. Because we have to state that the parameter is equal to something and then show either it is less than that value or greater than that value, okay? Or not equal to that value. So here are the possible ways in which we could state our hypotheses. One is that the research hypothesis, let's start from that first, that we have an observation where the mean is actually less. The value that we observe is less than the mean. So in other words, we're trying to prove that mu0, which is our observation, or what we want to test. So we have evidence that the mean is less than a particular value. So we'll assume that the mean is greater than or equal to that value. All right? Then we have the reverse of that, where we want evidence that the mean is actually greater than a particular value right here. So what we will do is we will assume that it is less than or equal to that value. The 0 should also be here as well, right? And then sometimes we want to prove that is not equal to. So let me just give you a scenario here with our last problem that we talked about, okay? So if we were talking about, we assume that the average score on an exam is 66%. I could ask you, is there evidence that based on a sample, if I found in a random sample of 50 students an average of say 60%, I could ask you, is there evidence that the true mean is less than 66% or different from 66%? I would not ask you if it is more than 66%. Why? Because my sample evidence is 60. 60 is less than 66. So I would be interested in either one of those two, which is that the true mean is actually less than 66%. And then a skeptic in me will say, which is my null hypothesis, no, it's greater than 66% or equal to 66%. Always remember the equal sign is in the null hypothesis. Or I could be testing that it's just not equal to. So my research hypothesis in this case would be that the average mark is not 66% versus the average mark is 66%. So I'll believe the null hypothesis, HO, and then I'll try to test that is not 66%. Okay, does that make sense? So that's the example that we would be testing. So in this case, I will be looking for evidence, sample means that are smaller than 66 if I want to support my null, my research hypothesis in this case. In this case here, I would look for sample means that are either much larger or much smaller than 66. So if I got 80, that's not equal to 66. If I got 40, that's not equal to 66. So we refer to those cases as, this case would be a two-tail. Two tails meaning that we would look for extreme values away from the 66 in either direction. But in this case of where the mean is less than 66%, we would be interested in looking at evidence just in the bottom tail. In other words, where the sample means are smaller than 66%. All right? And so we're beginning to get the idea that the sample must provide evidence to support the alternative hypothesis. If we want to test that the mean is greater than a particular value, I need sample evidence that's larger than that. If I want to test that is smaller, I need sample evidence that is smaller than that. Okay? Good. So here's an example that we have here. A major West Coast city provides one of the most comprehensive emergency medical services in the world, operating in a multiple hospital system with approximately 20 mobile medical units. The service goal is to respond to medical emergencies with a mean of 12 minutes or less. That's the goal, 12 minutes or less. The director of the medical services wants to formulate a hypothesis to test, right? A hypothesis test that could use a sample of emergency response time to determine whether or not the service goal is being achieved. Okay? So whether or not the service goal is being achieved. So if we want to prove that the service goal is being achieved, there's kind of two ways to do this, right? One is to get evidence that the values, from sample values, that's actually less than that. But if we want to show that it's not being achieved, then we want to find sample values, right, that are greater than 12 minutes. In other words, if I got a sample mean of 18 minutes, whoa, that's not being achieved. But if I got a sample of mean of 10 minutes, then I am achieving the values, right? So here's how we would frame that. Our null hypothesis is, remember, the one that we're going to assume is true, but the research hypothesis is the one that we want evidence to support. So what we will do is we will assume that they are in fact meeting the response time. And then the alternate hypothesis is to show that they are not meeting it. Okay? So we would look at the evidence that we have. So Mu is the mean response time. And so we would do something like this. So before I come back to that. Well, we don't actually have the values over here, but let me just put this down for you. So in this case, we would say there's no reason to disbelieve the hospital. So what we're going to try to do is we're going to try to prove that it is greater than 12 minutes versus that the mean is actually less than or equal to 12 minutes. Always remember the equal to sign has to be in the null hypothesis. So HO, the mean is less than 12 minutes. Versus HA, the mean is greater than 12 minutes. So if I'm looking for sample evidence to support my research hypothesis, I want sample means that are greater than 12. Any sample mean that I get should be larger than 12. And then if it's sufficiently larger than 12, it stops, it doesn't look like 12, like it came from a population with a mean of 12, so sample means of 15, 18, 25, 30. Then I'm getting evidence to support me. But I need to measure that evidence. And that's where it takes us back to chapter 7, where we will find the probability of finding the sample. Just the same way I found the probability of finding a sample of 50 students with an average of 80, we're going to do the same kind of thing in this problem. All right? So I have a problem here for us that we can form the hypothesis. So a manager of Danvers Hilton Resort Hotel stated that the mean guest bill for a weekend is $600 or less. Look at what they're stating now. Oh, it is $600 or less. A member of the hotel's accounting staff noticed that the total charges for guest bills have been increasing in recent months. The accountant will use a sample of future weekend guest bills to test the manager's claim. Form the hypothesis used to test the manager's claim. So which one would it be? Would it be that the mean is greater than or equal to 600 as the null versus less than that? Or is it the case where that our research hypothesis is that the mean is greater than 600? Or is it that our research hypothesis that the mean is not 600? The first case it was that the mean is less than 600. But if we go back to the question, notice what it says here. It says that the accounting staff noticed that the bills have been increasing. The accountant will use a sample to test the manager's claim. So what we're going to do is assume that the manager's claim is correct, which means the null hypothesis would be that the mean guest bill is 600 or less. So that's what we need to look for in HO. See, HO, we're going to assume that it's 600 or less. But the evidence we're going to look at is the fact that the average is rising. So therefore, the mean is greater than or equal to 600. So what is the conclusion when HO cannot be rejected? So if HO cannot be rejected, it means that we have insufficient evidence to reject the manager's claim. However, if it can be rejected, we have sufficient evidence to reject the manager's claim. All right? But to be able to reject it, we have to gather evidence and weigh that evidence. All right? So here we go. Here's another one for you to test. This is for you to test for yourself now. So a production operation is designed to fill cartons with laundry detergent to a mean of 32 ounces. A sample of cartons is periodically selected and weighed to determine whether underfilling or overfilling is occurring. If the sample data lead to a conclusion of underfilling or overfilling, the production line will be shut down. Notice that it said if the sample data will provide evidence of underfilling or overfilling. So that means either one of them is bad. You're looking for evidence that is under or over the mean weight of 32. Formulate an alternate hypothesis that will help to decide whether or not to shut down the production line. Okay? So let's do this. So the idea is that the fill rate is supposed to be, the average fill rate is supposed to be 32. If we want to find out whether or not we should shut down, we need to show that the mean is not equal to 32. So the mean is not equal to 32 would be our research hypothesis versus the mean is equal to 32. So essentially what you have is you'll be stating as your research hypothesis, no, the mean is not 32. And the skeptic in you will say, come on, it is 32, right? It is 32. And then you're trying to prove, no, let me see if I find evidence that it's not 32. So if we find evidence to reject the null hypothesis, we're going to shut down the production line. If we find evidence that we cannot reject the null hypothesis, then we don't shut down the production line. So that's as simple as it is. If I go back to the question, so I said, comment on the conclusion and the decision when HO cannot be rejected. So we have a conclusion and a decision. So the conclusion, if we cannot reject HO, that means we cannot reject the company's claim, then we will not shut down. We will assume that everything is working fine. We cannot shut down the production system. However, if we reject the null hypothesis, it gives us a reason to shut things down. All right? Errors in hypothesis testing. Now, I've kind of alluded to that already early on, but it makes sense to kind of just go over it again. So we have some special definitions. Type 1 error. So now that we know that we can reject or not reject the null hypothesis, so we could actually make some errors. Sometimes it's necessary. You should have rejected the null hypothesis and we didn't reject it. The sample evidence wasn't strong enough. It's like we should have found that person guilty, but we just didn't have enough evidence. The evidence was circumstantial. I like watching these sort of, legal shows. Anyway, so because hypothesis tests are based on sample data, we must allow for the possibility of errors. So we have one which is called a type 1 error, which is rejecting the null hypothesis when it is true. So if we conclude that the mean fill rate is not 32 ounces, then in that case, we would reject the null hypothesis. But what if it is? And we just happen to find a sample that made us do that. So we have an error. The probability of making type 1 error is called the level of significance. So that is where now we get into this whole idea that I tried to introduce to you some time back about something being significant. So the level of significance is that probability of observing the sample data if indeed the population parameter that we assume is true. So if, for example, we go back to our example with the average on a test, 66%, right? If we're going to assume that, and then which is HO, and then HA, we wanted evidence that the mean is greater than 66%. And then I found the probability of 50 students having an average of 80. That probability was less than 0.1%. That's called the level of significance. So that's what I mentioned to you, that small probabilities are significant. Well, the level of significance is the value of that probability. All right? So we have the Z value, which tells us how many standard deviations, and that probability tells us the significance level. And the smaller it is, the more significant it is. I know that people tend to associate more being larger, but in this case it's the reverse. The more extreme or the smaller the probability, the more significant it is. If snow is not supposed to happen in July, that's a very small probability, and it happened, that's significant. Oh, that's very significant. But if snow falls in April, there's a pretty good chance it will fall in April. That's not significant. All right? So we measure significance by probability. Keep that in mind. And so the chances of committing type 1 error is actually that value that we calculate, because we will reject the null hypothesis based on that value. If it's small enough, and you could ask me, then what is small? And generally, when it is 5% or less, we start to say that's a small enough probability. So that it means that the chance of making a mistake is only 5%, because that's the only time we will reject the null hypothesis. So if we use 5% as our the maximum level of significance, as the point at which we see something is small, that is when we could commit type 1 error. And then, of course, type 2 error is failing to reject the null hypothesis when it's false. Something to keep in mind, all applications of hypothesis testing are always based on us controlling type 1 errors. We cannot control type 2 errors. And that is because to control a type 2 error, you must know what the actual population parameter is, but we never know. So therefore we cannot control that, right? Type 2 error is accepting HO when it is false. So basically, if I have evidence that the average mark is now greater than 66, but I was not able to conclude that, that means I have to accept that it's still 66. That is an error, okay? And so we call that type 2 error. And type 1 error we denote by alpha, type 2 error we denote by beta. And so this is beta right here, type 2. Type 1 is alpha. So it is difficult to control the probability of making type 2 error. Statisticians avoid the risk of making a type 2 error by do not reject HO and not accept HO. So they say do not reject HO. So if you do not reject HO, you avoid the risk of making a type 2 error by using do not reject HO. Because rejecting HO when it is true is type 1. Failing to reject HO is false. So failing to reject HO when it is false is type 2, which is what we have here. All right? Good. And so the case of the court case that I spoke to you about is an example of that. Population condition, but this diagram gives us a good summary of the errors, but of course when we use guilty, not guilty, it makes it a lot easier to see. So the person is, that's the truth right here, and so the person is innocent versus they're guilty. These are the truth on the top, but the conclusion that we make is that the person is innocent or guilty. So if they're innocent and the truth is that they're innocent, then the correct decision is made. If they are guilty and we find they're innocent, then we made type 2 error. If they are innocent but we find them guilty, we rejected a null hypothesis when it is when it is true, is type 1 error. And then if they're guilty and we conclude that they're guilty, then we've made the correct decision. All right. So that is the summary of the errors in this case. So let's look at this last question right here. Carpet line salespersons average $8,000 per week in sales. Steve Contois, the firm's vice president, proposes a compensation plan with new selling incentives. Steve hopes that the results of a trial selling period will enable him to conclude that the compensation plan increases the average sales per salesperson. So develop an appropriate null and alternate hypothesis. So that's the first thing. So he wants to test that it actually increases the average sales. All right. So this is an incentive plan. So I'm going to show you how we put that both in words and in terms of numbers. Let's start off with words first. I'm going to try to stay over here so that I keep the question nearby. I use black since it's on white. So develop the hypothesis. In this case, the hypothesis, HO. No, let me do that. I need a little more space. HO, HA. So what we want to show is that the compensation plan increases average sales. So that is what we're going to try to prove. Compensation plan increases average sales versus compensation plan does not increase average sales. So if it increases average sales, the mean would be greater than 8,000 per week. But if it does not increase average sales, that does not look like a mean here for me. Mean, But if it does not increase it, then it will be 8,000 or less. All right. So that's the hypothesis. What is type 1 error in this situation? So type 1 error in this situation is rejecting the null hypothesis when it is true. That means concluding that the plan increases sales when it does not. Rejecting the null and supporting the alternate hypothesis would be to conclude that it works when it does not. The type 2 error in this case would be failing to reject the null hypothesis when it is false. In other words, you did not conclude that the program actually helps when in fact it does. Okay? So failing to reject the null hypothesis. So if I basically have not rejected the null, so I'm not refuting the claim that it is less than 8,000, the sales is less than 8,000. In other words, I'm not supporting this claim. So if I'm not supporting this claim, it means that I am failing to conclude that the project works or the plan works when in fact it does work. Okay? And that's how we would do that question. That brings us to the end of the first part of hypothesis testing. And I have a follow-up video on that will show you how we do some calculations, how we set up the entire test procedure. Okay? So that was video number 2. You have one more to watch, which would then be the equivalent of our lecture for Tuesday. Thank you.